All right, in this video, we're going to tie up the game. We're going to finish it up in this one using the helper functions that we created last time. And we're also going to tie in a couple different sort of a mathematical perspective on that number of guesses that it should take a user in order to be able to do this problem. So let's talk about the max number of guesses first. So if I gave you n being 2 to the 0 power, meaning there's only one number, then it should only take you one guess in order to get that one. If you're given 2 to the 1, which was two numbers, 1 and 2, then the way I've sort of written it out here is I can guess number 1, and then the computer is going to tell me if I'm wrong, then it's going to tell me the secret number is greater than the one that I guessed, and then we'll find out 2. So it's going to take me 2 number of guesses in order to always get the answer if I only had 2 numbers. The next one is if I had 4 numbers. So if I had 4 numbers, I'm going to break this thing up into two pieces, and I'm always going to, so my algorithm, sort of the way I think about it is I'm always going to choose the smaller one. So I'm going to choose 2, and then the algorithm is going to, or the computer will tell me it's either greater than or less than. If it's less than, I know the number is 1. If it's greater than, then I need to do the same business that I did up here by selecting the lower number, and then if it's not the lower number, then it's the larger number. So it must be 3. Come up to 2 to the 3rd power, meaning I have 8 numbers here now. And so again, break it up into 2, choose the smaller number, the biggest of the smaller 2 numbers here. In other words, it's some number 4 or 5. If I choose 4, and the computer is going to either tell me to come over here to do 1, 2, or 3, or it's going to be over here to do 5, 6, 7, or 8, or I got the number right. So the assumption here is that I haven't guessed it yet. In other words, when I guess 1, well, the computer is going to take, or when I guess 2 here, it's going to be a 1 or a 3 and a 4. But I could have got lucky and guessed 2. What I'm trying to do is find the maximum number of guesses it's going to take me, given that I have 4 numbers. Given that I have 8 numbers, the maximum number is, if I use my algorithm, I break it up in the middle, choose the smaller of the 2 numbers that's in the middle, choose a 4. I'm going to have 4 numbers on the right and 3 numbers on the left. Well, we know 4 numbers. We already know that 4 numbers takes 3 guesses. So this idea of recursion is the fact that when I used the number 4 as a guess, and then I broke it up into 2 separate intervals here, well, then the most that I could take after that would be 3. So 3 plus 1 is 4. So that's why you get 4. But you could sit here and do the same business that I did here. You could do it again over here, but it doesn't make a whole lot of sense to do that. That's why I use this idea of recursion. Again, you come to 2 to the 4th, you get 16 numbers. You go to 8, you break it up into a 7 numbers, and you got 8 numbers on this side. And we know that 8 numbers takes us 4 guesses. So therefore, we know 4 plus 1 is 5. So it's going to take you 5, and so on and so forth. If you just keep kind of doing that. The one thing that I wanted to show here was the fact that, okay, this is 8, and it's going to take me 4 guesses. But what I wanted to show you was minus 1. So 8 minus 1. So 7 is actually going to be in this 3 guess category. And why is that? Well, you can see I'm going to guess 4. It's going to break me up into a 3 and a 3. And how many guesses does it take me to get 3 numbers? Well, we can sit here and sort of work it out. So if I know I'm on this side, then I guess 2 because I'm breaking this up into 2. And then I either know that it's a 1 or a 3. Again, you can do the same thing on this side. So if I know I have 7 numbers, it's only going to take me 3 guesses in order to find the actual number, if you do things correctly. Okay, so that leads us to this sort of idea over here. How many guesses is it going to take if I got 2 to the 0 when n is equal to 1? So I have only one number. When I have 2 numbers, my maximum is 2. Well, then I have, it's going to take me 2 guesses, right? So it's just coming from this information here. When I'm at 3, when I'm between 2 and 4, then it's going to take me 3 guesses and 4 guesses if I'm between 8 and 4, and so on and so forth. You can see that these gaps start getting larger and larger and larger. And oh, by the way, if we're at 100, well, how can we solve that? Because I don't want to sit here and do this every single time. So I have this equation. 2 to the x is equal to n. And then I find out, so take the logarithm both sides, you get the x over here and divide it out. And then all I'm doing is solving for x and then adding 1 to it. So that's the same thing. So if you solved for it, remember this was 2 guesses when I was 2 to the 1, and that's what I'm doing here. I want to add 1 to the number. Okay, so this is the math behind that. When you see that natural log of n divided by natural log of 2 plus 1 in our code here in a few minutes, you'll know that's where it's coming from. I'm trying to figure out, if you do things correctly, the maximum number of guesses that you would need in order to solve that sucker. And then we will talk about how to run from the IPython command. I know I probably showed you this before, but we'll just make it sure. And then we're going to add an argument to it. All right, let's get busy programming. So this is where we started off last time. I'm sorry, where we ended last time, right? So we made this table of guesses, and we had this testing area. So I'm going to get rid of all of this. I'm going to get rid of all this testing business. We could have left it in there if we're going to always run from the command line. But when I hit the green button here, it would run those things as well. I just don't need that. I am going to import, so we need to import a couple things. We're going to import math as m and import, and the reason why I need the math is the logarithm functions, and then we're going to import sys. I'll just import sys. In general, that's how you import sys. Most people use it like that, and we'll use it later on. I'll tell you when we're using it later. None of this other stuff is going to change, so all of that's going to stay the same. All of that's going to stay the same. And we're going to come down here and we're going to start using those helper functions that we just created. So I know we're going to come down here and the first thing I'm going to change here is I'm going to give it a max guess. So just like we just talked about a second ago, it's going to be m.log. Log is the natural log. I mean, you could use either one, it doesn't matter because you can end up dividing. So m.log. So again, this is just going to be some float, and what that lets us do is it lets us come in here and go, okay, well, if my secret number is not equal to guess and num guess is greater than max guess, then I want to get out of this as well. No, when do we want to run it? My bad. It's got to be less than. So if it's less than is when it will run it. If it's not equal to is when it will run it. If it becomes greater than, then it will exit out, and that's what we want it to do. The next part here is just simply going to use the stuff that we've already done, or that we created, our little helper function. So I'm going to have guess, comma, let's see, we can call it validate, and then we're going to send in guess list. We had to create this. We haven't created this guess list yet. So right now, inside this function, guess list is just going to be equal to an empty list. But we'll see here in a few minutes. We're going to create this thing. We know what we want it to look like. We want it to look like that thing I just deleted, which is a number and then a greater than, less than, or equal to. The next thing is I don't always want to increment num guess. I'm not sure if you remember, but if I do h, then guess is going to be equal to a 0. So if guess is equal to 0, so if guess not equal to 0, then I want to increment it. In other words, if it's equal to 0, I don't want to increment it. In other words, it was hint. I don't care about, so hint's going to do its thing, and I don't want to increment it based on hint. What that allows me to do is get rid of all of this. So I don't need the hint stuff anymore. The hint's going to be taken care of, and then it's not going to really affect it at all. So we're going to take out that. Let's see what else. Oh, we can take out this upper business. I don't need that anymore because the validate function does that for us. And I also don't need this because the validate function is going to do that for us as well. A lot of those things we had in there just so that we can make it work the first time. But once you've sort of figured out what you want this thing to do, then or what you want your validate function to do, then you can take some of that functionality out of your main program, which is kind of what you want it to do. And in this case, when we equal to the secret number, what we want to do is not only do we want to set when equal to true before we break, is we also want to do some other stuff, right? So remember that guest list that we talked about? So guest list dot append, and what do we want to append is a list. And what is that list equal to? Well, it's the guess, whatever it was, however we want, right? So I want to record the fact that I just found my secret number, and the way that I show that is a double equal. Just like Python, if it's when you're doing a comparison, I'm just going to let that be my thing that tells me that it's equal to, and then we can execute our break. If secret number is greater than guess, then we want to do something else as well for our guest list. So guest list dot append. Again, we're going to put in the guess, but then this time we want it to be what, greater than, right? Because we want secret number to be greater than the guess. Then down here we want guess list dot append. We want it also to be if that's true. Well, secret number, do we always want it? Oh, yes. We need to change this bad boy, right? So I need to change this because if secret number, if guess is equal to 0, I don't want it to do this. So and guess not equal to 0. And I'm going to change this, instead of always executing, if all of that other stuff failed, I'm going to redo this one as a secret number is less than guess. Okay, so when you're doing these if statements, you sort of have to figure out what's coming out, and then what exactly do you want to have happen in your code. In my code, if it's greater than, then I want to record this, and then I want this to come out. When it's less than and not equal, and the guess is not equal to 0, in other words, that is a hint, and then I want this to come out. So that's the idea behind this thing, is you have to tell the computer exactly what you want, and you got to kind of think about it too. And then finally, if I win, then not only do I want to print this out, but I also want to print out the table. So table of guesses. This will show you the one that all of the ones you had done previously, and the one that was the winner. And then maybe okay, so let's if length of guess. So just in case someone hits quit right at the beginning, I don't want to print out an empty table. So table of So what this prevents is if someone hits quit right at the beginning and you didn't record any guesses at all in your data structure, then you want to just not to do anything. You just want to say, hey, better luck next time, and then tell them what the secret number was. All right. That's all that we need to change in here in the main sort of program, the main function. Down here, I want to change it so that if I execute on the IPython line and I change in, then I want it to do something maybe a little different. So we're going to say print. So first of all, I'm going to get rid of I'm going to put a bunch of blank spaces in, because I don't want the stuff right above here. So if I hit the go button, or if I do it, I want it to get rid of some of this printing stuff. And the way I do that is, I want to multiply it by 10. So this is 10 new lines in here. And then I'm going to do another try. So I'm going to try, and the reason why I'm doing that is just in case someone puts in something funky in there, like a string or something, or a float. I don't want any of that to mess us up. So int sys. So this is where I'm importing sys.argv. So arguments, so variable arguments, and then 1. The 0th one is the name of the function. So if I had the 0th one, it would be, in this case, it would be vid7_2. Matter of fact, let's save as. Let's do the save as, and I'm going to say vid3. So it would, so sys.argument_v would be, if we typed it in over here, it would be the name of the file. So this vid7_3.py. I don't want that. I want whatever comes up after that. So we're going to let n equal that. So n is equal to that if it's a number, if it's a float. Except e not good, then we'll do n is equal to 100, and then we'll bring our main back outside the except statement. Okay, so what is this doing? Print is getting rid of all of the stuff above it. N is trying to set it equal to, so if I don't have anything there, then it'll just come down here and let n equal to 100. If I have some other number there, then it'll change n to whatever that one is, and then it will run main n, and then main n starts off here, right? So if I don't have anything else declared, then it's 100, and then it'll just sort of go through and do its business. Okay, so let's just run this thing and see how we get the spaces, and then 50. So the number's greater than 50. So the number. So if I don't remember, if I can't remember all of the sort of clues that it gave me, this thing will sum it up for me. So I can come here and say, well, the number is between 50 and 75. So maybe 12. Let's see, it's 25 in between those. 12, 62 would be the next number. Number is greater than 62. So let's get a hint. So now we find out that we were between 75 and 62. And there's what, 13 in between those. So 6 plus 62, 68. Secret number is less than 68. So again, we can hint it out again. And then we know we're between 62 and 68. So that's a 4. Is that 4? 6. 6 numbers in between. So 3, 65. Number's greater than 65. So again, let's hint it out. So we know we're between 68 and 65. Maybe 67. And we got it. All right. So this is what happens when you win. Congrats on guessing the number. It took me 6 tries. And then it just sort of summarizes everything that happened. The last thing I want to do is run it from the IPython notebook. So you go run, and then you type in the name of the vid 7_3, right? And then we'll put in 8. So the 8 will be my number. And when it does it, you'll see that this changes. Enter your guess, a number between 1 and 8. And you can put in 2, 6, and we got it right. So I got lucky that time. We can run it again. You can put in 1,000 if you wanted to. And so now I get some number between 1 and 1,000. And it ends up being we can very quickly, so we're less than that, so 250. Let's see, how many times would it take me to get to be less than 100? So now I have 125. So it's greater. So it's some number between, remember, some number between 250 and 500. So that is 250, 125. So 375, I believe, is the next one we should guess. And H. Just makes the math a little bit more difficult. And you can see if you press quit. Better luck next time. The secret number is 338. So how close were we? Oh, we were relatively close. But all I wanted to do is show you how to run it from the command line. Okay, that's all I got. I will talk to you next time.